When we talk about data-oriented programming, we always wanted to make our applications faster, better, less complexity, blah, blah, blah. How do you supply that? Now, when we talk about a few modern Java features, a couple of modern Java features that I would be discussing in my session today, like records, pattern matching, and seed classes, those are the ones that would supply this demand of working with data-oriented programming, which would, of course, offer benefits. What? We'll see. So the first question here is, what is data-oriented programming? It has multiple points. The first one is the most obvious: model data as preferably immutable data. It might seem very obvious, but it is not, to model data as data, and we'll see that in this session. And the second one is to separate data and behavior. We have been doing that for quite a long time now. We talk about entity classes, we talk about data access object classes, services. So we have been doing that a lot of times, but now with the new Java features that I mentioned in the beginning of the session, we get to see a lot more opportunities where we could apply the separation of data and behavior. And when you talk about data-oriented programming, you talk about not in the domain of Java, but multiple other domains. And a lot of other languages like JavaScript, they use other generic data structures like struct, which we don't have in Java, but you would kind of hear this term in the other languages as well. So this particular point, though it's relevant to data-oriented programming, it's not applicable to Java in the scenario that I would be talking about. Never mutate your data. Anyone knows why? Any answers? Spot on, that was spot on, because we don't want the data to change when we pass it to any other application. We don't want the data to be a function of time. We want it to be as it is when it was given to the time it was delivered. And we also talk about separating the data schema from data. When I say data schema, I'm talking about metadata. So a lot of times we use data schema and include that as part of our data, which we should not, because that is what should be preferably defined as the logic, should go into another class, not defined as part of the data. Now, of course, the big question was why data-oriented programming? Because it reduces the complexity of your system. And as I mentioned, I would be covering a couple of Java features, which is records, seed classes, and pattern matching. The other big question is, why are we talking about data-oriented programming now? Because there has been a lot of changes in how the applications are developed. We're talking about smaller program units, we're talking about smaller teams, and of course, as I mentioned, because of the new Java features that I would be covering, it really helps it to make the process a very simple one, because we could be talking about going to the moon or going to the Mars and having our whole space here. But what if we could Uber there? Then it would make sense. So that's how both the pieces fit in. As I mentioned, data, not so obvious, because we could be talking about data, the obvious data, you store the details of a person, different details of another person. We could be talking about shopping cart or shopping item. Yes, JSON is data, and this is an image which I used for an application for design students at a college, where they use color cards to choose the color palettes for their projects. So this is again data as well, and we know CSV file, all of that is data. Not so obvious data. Where do we see that one? When we talk about the complex return types of a method, what if we have to return multiple types data points from a method rather than just one value? What do? We use collection classes. Let's see if we could use the modern Java features and define our logic using those, instead of using map and structures and other collection classes, and then using logic to decipher that data. The other is we use string to pass around a lot of our data, which is of course not so obvious. The logic is defined in another method. Specifications like the JSON with the modern Java features that I would discuss, you could actually define the structure of JSON in using sealed interface and a couple of record classes. Now, before we begin, one quick question again, which is the difference between the syntax and the semantics. That's a big one, because a lot of time when I talk with developers, we talk about the syntax, and a lot of the usability of the feature is kind of the developers don't reach to that stage, and they just stuck on the syntax point. Now, there's another quick exercise for all of you. Without stating the name of this animal, tell me how would you describe it? Could be a phrase, could be a word. Roar. King of the jungle, very strong.
National symbol.
National symbol of Holland. Okay, of Holland, yeah.
Leadership quality.
Sorry?
Leadership quality.
Leadership quality, yes. Okay, so we did talk about a little bit of semantics as well, but the usual answers that I get are main, brown in color, big cat, carnivore, things like that. So we are stuck on the syntax part. So as I mentioned, we also covered a bit of semantics here, which is good. And how do you use a lion, or probably they use us? That's another topic. So you could have lion as a pet to scare away your enemies. You could, but if you don't have this as a pet, don't leave your pets near a lion, because you won't find them again. The other one is run for your life. If you see a lion, of course. But how could you make money out of selling something to the lion? Shampoo for lions, mane? That would be a good one. And the hair braiding services. So again, that would be another application of how we could use a lion. So in a similar way, let's talk about the features that I mentioned. So we'll start with records. How many of you have used records here? Okay, just a few. So the way you define your class, records lets you define a type, and the syntax is quite concise. Let me show a quick demonstration to you. Let me hop on to my IDE, which is, of course, as you would know, IntelliJ IDEA, JetBrains. How many of you here use JetBrains? Oh, sorry, IntelliJ IDEA. Wow, that's a lot. Okay, so let me create a new. Before that, let me bring up my image, which I mentioned in the first part. And let me, what happened here? Okay. So now I want to create a record, and the name of the record is palette to colors, and I want to make it a record. So what were the components? Let me bring Shift and enter, Alt and enter. What happened? How do we split the windows? Split, oh, Shift and enter. This is what I was doing. This is funny. Okay, that no problem. And this is how I would define. So as I mentioned, this on the left you would see a palette of cards which I've used for the design students for a college. And here, let's say I would define this record. The second component that I want to define is color. And let's say I name it as color. The third one is again a color. And now this is how I would define a record. And what's special about a record and a regular class? This is a compact way of saying that this is the design of my the objects that I want to create, and these are the components. The components are here. and the compiler would automatically generate your getters, not the setters, because all the components are final. If you recall, I mentioned about defining data as immutable data. So this makes it, you're sure that the data that you're defining is immutable. Now, the other point is, what do we want this class to do? Usually when we define a class, we create constructors so that we could modify something or test, validate the values that we enter or use to construct this. Again, you can add constructors to a record. There are two types of constructors here. One is the compact one, which would not have the set of parameters that you pass to it, because usually when you have a type, you see the components that you pass to a record. In this case, that is implicit because they are the same that you see up here. And of course, what would you like to do in your constructor? Let's say I have a cheat code here. So what I'm doing here is I'm just verifying if the values that are passed to this constructor, they are null, and the bottom lines don't compile because, okay, they don't compile because I cannot modify the values in the compact constructor. To do that, I would need a canonical or a complete constructor. Again, I can overload constructors the way I do for every other class. This is how I might define my other constructor. In this case, the first line of code that this constructor needs to call is the constructor. How many of you know that this might change? We might be able to, wow, that's good. Impressed. So there's a new Java JDK enhancement proposal on the way, and that would change how you call this line of code, because now it's mandatory to call this as the first line of code, but this might change in in a future Java version, don't know when, where you would be able to have additional code up here, and then you would be able to call your constructor. So calling this would not be mandatory. Now, if I go back to what I mentioned in my introduction, the reasons why we are doing is the immutability. I can just close this one, and what if, so this is again a set of code that I just inserted. Okay, so this is alt and enter, import. Now this is fixed. Now in this case, what I'm trying to do is I'm trying to create instances of the dated class that I just created, and now I'm using reflection to change the name of the field name. Do you think I would be able to change the name? Yes. Okay, for no? Sorry? Yes, that's right. So if I try to change the name via reflection, the reason I mentioned reflection is because how many of you know that string class is immutable? And how many of you did try to change the contents of a string class using reflection? Wow, I could assume that. Okay, a couple. So you can change the contents of class string even though it's defined as final. So this is what is different with records. You cannot change the components of record since they are final. Of course, if we are talking about the components which are collection objects themselves, we cannot change the object that has been assigned to that, but of course the objects or the values that go in that collection class. So if it's an array list, I can change the values that go in the array list. I could increase or decrease that, but the array list itself cannot be changed. So that's immutability. And the other one is the collections demo that I wanted to show you. Now, okay, I have to create a class person first. So in this case, so this is a class person, and what I'm trying to do here is string name, and this is a constructor. And now let me add the getters and setters. Now what I am doing here is, this is a simple class person with name, with just one field which is name, and getters and setters, and a constructor here. And now if I go back to the collections demo class, what I'm trying to do here is I create two instances of class person, and then I create an array list where I add just one of them. Now in the last line, what I'm trying to do is retrieve gets2, which has the same name, from the array list. What do you think would the answer be? Would that be a false? False, okay. And how many people think that would be a true? Okay, no answer. Okay. So what happens here is, because the record class, now, this is not a record class. Person is a regular class. And if I go back to my class, which is person, yes, I did not override the hash code and equals method, which the collection class is required to retrieve the values when they search for it. Now, if I go back to my demo class, this is what we usually do as developers, even though the IDE can help you to insert and add the other methods that I just mentioned. The probability is not 1. The probability is something where between 0 and 1. So we could miss that, and a lot of time we miss that, and then we get a lot of errors later on. So if I define, let me go back to this person class, and before I do that, let me just run this so that we know that this is returning a value of false. So yes, just warming up. Yes, so you see the value false here. The ones who are sitting here may not be able to see, but this prints false for sure. And let me close this window here, and if I go back to person class, why can I not convert that to a record? Usually I get that part here. That's okay. Just let me convert that to a record, and I would delete all this. So this is a record and not a class now. And if I go back to my collections demo, and if I run this now, you would see that when I run this, it returns a value true. Now this is the benefits of defining your records class. The data is immutable, so you can be sure that the threading, the multi-threaded programs, they do not give you a lot of surprises. It works well with the collection classes, and it's, now let me go back to my presentation. Now see the difference between the amount of code that you would need for a record and the amount of code you would need for a regular class. So the cognitive code is very low, because even the IDE can generate everything for you, but as a developer you would have to read all the code and make sure that it's still a data class and it doesn't have those extra methods, or the default methods have not been modified. So this is one of the biggest benefits. So we covered the records is a new data type, it's compact, and we did not see, because it's immutable, you would not see the get method. The name of the methods is the same name as the name of your components. So color 1, color 2. So that would be just the color 1 and color 2. It has it automatically overrides and gives you the default implementation for two-string hash code and equals. Of course, you can override them if you want a different implementation. And I talked about the compact and canonical constructor. You can also add annotations to your components. So in this case, we are talking about a generic record. You could have a generic record and also add annotations to its components. And you cannot add additional variables or fields to a record, but you can, of course, add static fields. And the reason why addition of instance variables or fields is not allowed, because we want a record to be known by the components which are defined its declaration, and we're not making it more confusing by allowing anyone to add the fields later on in the class. So I talk about conciseness, immutability, and the implicit support, and we've already talked about that. And of course, you can use records to define your value objects, your data access objects, and your entities. So whenever you are hearing about any new feature, or for that matter, anything about whether on your own or from a speaker, the best way to learn about a feature is to ask about what are the drawbacks. So anyone would know what are the drawbacks of records. Sorry? No. That's one. That's a good answer and a drawback. That records, they inherit the record class from the Java API, so you cannot make it inherit any other class, any other. That's right, because the data classes are immutable. You cannot use them with a framework like Hibernate, which modify the value or the components of an entity after they are created, because I assume a lot of you have used Hibernate, which uses the default constructor to create an entity without any values, and later on it populates that. So if we are using records, probably the best would be to create the entity when you have all the values. Hibernate doesn't provide this as of now, but I'm sure they would do that. Otherwise, they'll fall short, and people would look around for workarounds, because that's what developers are good at. So now let me talk about sealed class. Yes. Come again? I didn't get the question. Does Yes, the way you can create your regular classes could have the fields of any type. In the same way, the records could have the components of any type, because the example that I just showed you, the components were of type name, they were color and color. So all of them were classes. You could have primitives as well. So it's the way you do that with your regular types, regular classes. Yeah.
What about serialization? Can I use it to send that over the network?
You'll have to implement the serializable interface, because it does that automatically. So you just say.
Have it implements.
Yeah, of course. Like a regular class, you can make it implement any n number of interfaces, but of course you cannot extend it from another type. Records were made a permanent feature in 16. They were introduced in Java 14. So Java 17, which is the latest version, has it, and any other later than 14 would have records. So now let me talk about the sealed classes. How many of you have worked with sealed classes here? Naveen, of course. Yes, okay. So sealed classes again was introduced, made permanent in Java 16. And if you look at the Java API also, it has a lot of usages in Java API as well. Now, when we talk about inheritance, before sealed classes, what were the two options? Either a class was non-final or the class was final. When I talk about a class being final, no other class can extend it. But when I go to the other spectrum, if a class is non-final, any class or interface could extend it if it could see it. if what I mean by being seeing is being accessible. If a class is accessible, it could be extended. But with the sealed classes, we found a midway in which the sealed classes decides which other classes can extend it. So it has a permits clause. It says, let's say I have any class. Let me go to my, okay. So let's say if this is an example and these are the Lego blocks, which of course are made by the company, the company wants to control which other Lego blocks could be created in a production unit, etc. So it could say that I have a character Lego, which is a panda here, or these are the square Legos, a rectangle, and a tower which has, let's say, 5 or other number of blocks. So now here the Lego interface could declare what is the hierarchy of that interface, and that could apply to a class. So even though the title is sealed classes, it applies equally to interface as well. So sealed classes means sealed interfaces and classes. And the benefits, of course, are you can control which other classes or interfaces extend your class. And why would we want to do that? Because we don't need other workarounds like making our classes or interfaces private, because that's what we have been doing until now, making the classes or the constructor private, or we define the classes interfaces with default visibility so that it's not visible. We just kind of try to hide it, which is no longer the case. Now let me quickly show an example of this to you. So the demo sealed classes doesn't has anything, which means let me create an interface, and the name is Lego, and I want to go back and view the image. So let's go back, and the Lego blocks are here, and this was Alt and Enter, Shift and Enter. Now this is working. Now I want the image so that I can see what's happening here. Now this, I can say that this is a sealed public interface. Now it says a red squiggly line because it needs which other classes or interfaces extend this. So so let me look at character. So I'm creating a couple of records which would implement this interface. So let me start with character Lego, and here I say that the name, the component that I want to pass to this record is, let's say, a name, and this would be string name. And then I want to create a record which is, and this implements Lego interface, and this is another record which is square Lego, and here let's say I want to pass color as the parameter because I see different colors for this Lego. Color. And again I have to write this implements Lego. The next record that I want to create is, let's say, a rectangle tower. Rectangle Lego, and here I don't really want to pass anything. This again implements Lego. And the last one that I want to create is square tower Lego, and in this case I want to pass the number of blocks that you can see in this star. Again, it must implement Lego, which is the sealed interface. Now in this case, what you see here is an interface Lego, and there are 4 records, and because the records are implicitly final, we do not need the keyword final here. The classes that extend Lego should be of three types. Either they should be final, they should be sealed, or they should use the non-access modifier non-sealed. Final, everyone knows what the meaning is. When we talk about sealed, I just talked about the sealed classes. It lets you define your hierarchy declaratively with you controlling everything. Well, when I say non-sealed, that would be a regular class, but because we are talking about when I say a sealed public interface Lego and then I make it implement, then I let it extend. Sorry, I'm missing the words. If I have another non-sealed class which implements Lego, then I say, okay, I know that this non-sealed class is extending Lego, and Lego knows that this class is being extended by this. Now this is free to go and make it, this class could behave like a regular class. So, and in this case, I do not use the permits clause here. I could use it, but that's not required, because if this is permits, character Lego, I could use the permits clause here, and I could list all the records which I just defined here. But that's not required in this case because all of these exist in the same source code file. If they exist in a different source code file, then I would need them. And what is the benefit, you would say? This is how you could process the Lego class. So this is an example of a switch case where I'm passing a type of Lego, and in this case the case labels are 4. To be precise, this is an exhaustive switch, which means that every record or every type that extends the Lego is defined here, and I do not need a default clause. How many of you have used switch expressions, the new switch expressions which came in Java 12 later? 1, 2, of course. 3, 4, 5, yes, a couple. So when we use the switch expressions, we always had to use, how many have kind of been through the process of the painful debugging when you missed a break statement in the switch? Everyone, yes, we know that. So that takes away a lot of pain. When we talk about the switch expressions, we do not need the break label anymore, because we can just skip that part, and then we know that every case label, what you have on the right side, would be evaluated without needing a a break statement, and then the block of code would exit. In this case, what I'm doing here is the regular switch accepted a very limited number of types. It was not all primitive values. We did not allow double and one more, and just string and enum. But now you can pass in any type here. So here I'm passing Lego, and sorry, is there a question? Okay. So, and I know there's a lot of content here to digest. If anyone has any questions, because I'm unsure which part should I cover and which part should I skip. If there's any question I could address. Yes? Okay, you're good. Okay, since there are no question, I'll move forward. Of course, I'm here throughout the day. If anyone has any question, just come to me and ask. So this is how the processing of the states of all the types of a sealed class becomes very easy with a switch case. The other analogy I have is assume that you go back home, you're married and you have kids, just assume that. And you have 2 kids, that also you can just assume. And your spouse says, so what is the gift that you got for the elder child? You say, okay, this is the gift. And the spouse asks, so what about the gift for the younger child? And you say, here's the gift. And then the spouse says, what about the gift for the rest of the children? Would that be a dumb question, an irritating question? You would be surprised. All of it, probably. So, I can see what you're doing there. Okay, so this is what has been happening with the if-else statements. You had to have an else block even though you cover all the valid states in the if conditions. If child 1, if child 2, you need to have an else block. The same with the, if you do not have the seal classes, you would need a default case. If Lego character logo, let's go back to the child class. If case child 1, case child 2, case default. No, we don't need that. We do not need to code the states which do not exist. So that's a big one of the main benefits of using your seal classes. This we've already discussed. Yes, we talked about semantics. It's to model the choices. If we go back to the Lego example, we modeled choices. We defined the choices that we want to have with the Lego classes, and we no longer need the workarounds about reducing the visibility of our class or the constructor so that no one can seize the classes so that they cannot inherit it. And of course, because the compiler is available of the choices of all the subclasses for a particular type, we can work with we can process the values much easier in our code. This, of course, is the application, and we also mentioned about coding for states, not coding for states that don't exist. Now let me talk about pattern matching. Pattern matching was delivered in 3 stages: instance of, switch expressions and statements, and record patterns. How many of here have worked with instance of? Oh wow, that is perfect. Switch expressions and pattern matching, yes, that is good. And record patterns. Okay, record patterns. Yes. Naveen, no. How can that happen? No, I'm just kidding. So record patterns is kind of a deconstruction pattern for records. What happens in a record, you create a transparent carrier of your data. These are the values that you want to kind of just transport from one place to another. You create a record. How do you use those components? You deconstruct it. So that's what a record pattern is. Now let me go to, okay, so pattern matching, I think we already know this. So I had a quick example. Let's say you want to say, compare what exactly is pattern matching. You are trying to match 2 things. So in this case, we have an object and a pattern. So when we talk about the pattern matching in Java, we have test patterns, type pattern, sorry. So we are comparing an object to a type. We say this object is of type string, of any enum or any other type. So, and the other one is the record pattern, where we are comparing an object to a type which is a record, and we also comparing it to the components which we define in the record pattern. So a quick example, does this object match a pattern? So if the question is this an animal? So probably these are the answers that you would get. And what if I want to refine the answers that I get? I would say, does this animal has yellow and black stripes? That would mean that I am refining what I want to search. So in this case, we would be left with just 3 values. And pattern matching for instance of, let me quickly go to my editor to show the examples. So let me just close this one and this one too. And so this is an example of pattern matching for switch. As you already said, you already have worked with the pattern matching for instance of. This is simple. I just deleted 1 line of code, but this is just the tip of the iceberg. What if I go to this class? In this case, I know the second line of code is not how you should write. If true, return true, but this is how we do developers all the time. So I could replace one variable, which is local variable, and I made that a pattern variable, and I could simplify this as well, and then I could simplify invert. Now this is what I land with. Now with this line of code, what I want to show is, by removing just one line of code, you have a lot of other possibilities. So of course in this case I could use IntelliJ IDEA and the inspections it offered, but it is of course not limited to an IDE. You can remove one line of code and then make your code much more concise. I have another example, and in this case again I am following the cues from the IDE, and I'm merging the nested if here. This is again merging, and now this gives me another possibility of using loop with collection dot remove. If I want, I could also inline this variable, which would again make the code concise. Again, the point that I'm trying to make is that when you use pattern matching for instance of, it can make your code really concise. There's another example that I wanted to show you for pattern matching for switch. As I mentioned, we talk about the switch statement and the break statement. There's another perspective when you talk about long if-else statements. That's another place where you could use pattern matching for switch. In this case, I can use a pattern variable here, and I can use a switch expression here. Now just look at the code that we had initially and the code that we have now. It's much more concise. It has a lot of the cognitive load is much less, because I can see all of the code in one go. And my favorite analogy for switch expressions and if else is, what if you are visiting a restaurant, and if the person who comes to take your order say, do you want this? And when you say yes and no, then he goes to the other option. Now do you want this? Okay, you say yes and no, and then he goes to the other option. So that's what an if-else statement to me is, and compared to that, a switch statement or a switch block is what you see in the menu right in front of you with all the options. So of course there are downsides of using switch, because when you use a switch, when you use an if statement, the conditions that you define, they could be much more complex. Not so much in the case of switch. The type must be same. Of course, you can add more conditions, but yes, there are different conditions where you would use both of them. Now, if I go back to, so this is one of the examples. I might not have time to demo the other one. Let me go back to my, probably I would use, now this is, I'm using a couple of slides because we don't have much time for the demo part. This is the difference between how you would use a switch statement in an expression. So this, probably I'll share the slides, and you can see that this is how you used break here, and now you can use this without a break. And of course, you can use this because we're talking about switch expressions. You can return a value using this construct. Now this slide has a lot to consume. Here we are talking about a record pattern. So all the case tables here are record pattern. This is the name, dish is the name of a record which has a generic type, and the components here, when they are included in the case label. So starting from dish to cheese, that's a record pattern, because what I'm trying to do is I'm specifying the type name in my case table together with the components. So that's what a record pattern is. And as you can see, I'm doing a lot here. the interface is a sealed interface, and then we have a couple of classes which are final classes, a record class. All of them are implementing this interface, and I'm using record pattern to, these are the dummy values, but of course you can you can use a lot of complicated evaluations here. I could also add a when clause in my case statements. I could say when dish this, when cheese dot, let's say value is equal to something. So I can use queries like the way you have in your SQL queries, and I could refine my the conditions, and that's way you can make your code concise but still readable. And now, since we've covered all the ground that we wanted regarding the new Java features, I have a few examples of data-oriented programming. So the first one is the CSV file. I'm sure all the hands will go up. How many of you have worked with CSV files? Yay! Okay, so this is a typical example of how you would have a CSV file converted to a tabular data so that it's easier to understand. But if you look closely, the data here is kind of, yes, in this one we have multiple data within an item. So again, change to tabular format for easier understanding. And what we are doing now is, this is how I could model that CSV data. This is important because a lot of times, because as I mentioned in the beginning of the session, why are we talking about data-oriented programming now? Because the programs that we write, that has changed a lot. And this is an example, CSV file, as you all said you have used a lot of times. When we consume any CSV file or a JSON file and we use that in our applications, we want to validate all that data at the boundary so that once it enters your program, it's valid data. And when you use the new Java features like record, pattern matching, so of course we cannot, you cannot see the usage of pattern matching in here, but that really helps you to make a lot of validations. And when you combine all of that, it really helps with the applications to make it more less complex. The one that I mentioned in the beginning. Now there's another example. So this, okay, I do have an example. Again, here what I'm doing is, these are dummy values, but I know the real applications are much more complex. What I'm trying to highlight here is, again, this is a record pattern where I'm breaking down the components here so that I don't have to use another set of local variables to use one of the values of the components of this record here. Again, it makes the code more concise, less complex. I know it's looking a lot complex here, but if you compare that with how you would do without all these sealed classes, interfaces, records, and then with the ones here, then it would look much less complex. Again, JSON data, we've all worked with that. This is the same data that I used as a JSON file. We could apply the same principles that I mentioned using sealed interfaces, record classes, and then using pattern matching to work with this. And this is again the example where I have this as another set of JSON. Now, a quick example on ad hoc structures. Now, we would see, this is one example. We know that the applications that we work with, we have ad hoc structures all across our applications. This is one of the ways in which I could think of for defining the point, line, triangle, square. These are the geometrical figures that implements the interface two-dimensional, which is again a sealed interface. And this is how I might use pattern matching for switch, which uses test types, which uses record patterns. to extract the values and return the value to me. And this is using, I think this is using a recursive function, because process is the method here, and this is again calling the process method. So again, as I said, an ad hoc example. Now I want to talk about expressing hierarchical structures. In the beginning of the session, I mentioned about the JSON specification. If you recall, the values that you pass in your JSON, they are either the type of a string, they are the decimal values, null values, boolean, and then you have an arrays and pairs. So if we talk about seal interfaces and records, probably I could define all of the JSON specification like this. And once I do that, that again opens another set of possibilities that I could look at to work with all these records and how I process them in my application. So this is an example of JSON specification. Of course, if I talk about the applications that we work with every day, we do see a lot of times that we work with similar complicated structures. So again, you could use the new Java features and model your structure and hierarchies. Now this is example from the Java API. How many of us love the option class, the option type? Yes, all, not all. Okay, the ones who didn't raise their hand, did they use it? Oh, I knew that. Okay, so once you use that, you'll come back to you could probably think about this. So there are a lot of sessions which tell you about how to use the option class correctly. So that explains a lot about the complexity that comes with using the option. So if C classes existed before, so this is from one of the articles by Brian Gates, who is the chief architect, language architect for Java, and he mentioned if we had the C classes probably way earlier, then this is probably how we might have modeled it, and that would reduce a lot of pain of using this type. And so of course, I know you would have a lot of questions for me, so I tried to turn the table around. Now I have a question for you before you start asking your questions. How would you model the data that you see a lot of times in your applications like this? Because I'm sure a lot of you would have written application that sends data like this or accepted data that comes in this format. How would you use the new Java language features so that you can model your data in a much more better way so that your applications could be less complex? And here the 1, 2, 3 is like how we encode the data. The first 3 would be the area code, then it would be the country code. So that's a lot of rules go in the data, and those rules are defined elsewhere. So probably it's high time we define the rules within our data classes rather than looking at multiple places. And I know I skipped a lot of details because it was not the time was not enough, and it would have been really overwhelming to cover all the details. I have a lot of details in the blog post and the videos that I create. The QR code is for the video playlist, which just has 2 of these videos now. And with this, thank you so much.